So again, that is just a screening process. When we are about to analyze the cash flow, we usually have some very intuitively strategic strategy to reduce the number or to screen the opportunity which do not meet the requirement or meet the requirement based on our strategy. But then once we have passed that point, we have a few alternatives that we want to select. Then we need to calculate them precisely so that we can make the decision that brings us the highest benefit that we can get. We can use benefit cost analysis, but equivalently we can do this net present worth analysis. So net present worth is to bring all the cash flow, everything, or you can first have net cash flow and bring the entire net cash flow to the present time, which is n equal to 0. And the decision rule, which is very important, as I said, the decision rule, if decision rule states something, you can only follow that, because if you did not convert the decision rule properly, you may mistakenly think that the converted one give us the same conclusion. So again, there's a decision rule. We follow what the decision rule tell us. We'll do it as much as we can. If we want to do it in a different methods, to make sure that the conversion between these two decision rules are consistent. Okay, so here again we have cash flow, and we can compute net cash flow. With inflow, we have outflow. We sum them together, or we take the inflow minus the outflow in terms of quantity. Then we'll get net cash flow. If the present worth of the net cash flow is greater than 0, we'll accept. Otherwise, we'll reject. Okay? Reasonable, right? We want to have net cash flow, okay, the present worth of the net cash flow based on certain interest rate. Okay, under that interest rate, which is something we defined, under that interest rate, if the present worth of the net cash flow is greater than 0, we'll accept this opportunity. Otherwise, we'll reject. We can look at example with the numbers. Here we have one outflow, at the present time, other inflows at the end of the first year, second year, and third year. Okay, so what we can do is we can compute inflow, the present worth of inflow. Then we can consider the present worth of the outflow, and we take inflows, the present worth of inflow minus the present worth of outflow. Then here in this example, the result is 3,553, which is a value greater than 0. So we'll accept this opportunity, this investment opportunity. We put in certain amount of money and we get certain money back every year. And if we take the net present value, okay, then NPV, net present value, the result is positive, which based on the decision rule we'll accept. So we mentioned that that analysis is based on an interest rate. Okay, interest rate. For the example, we use 15%. So there is a question you can think about, and you can probably figure out the answer. Just think of it more logically. We get 15%. We use 15% as the interest rate. We get the net present value, which is a positive value. Okay. So what if we decrease the interest rate? What will be the consequence? What will be the consequence? Will the present worth be bigger or smaller? And why? Similarly, if we increase the interest rate, and do you expect the present worth to get smaller, even from positive to negative? What do you think? So intuitively, you can think of it this way. If you are using an interest rate to reflect the accumulation of the value or the change of time value, you can imagine that for the investment, a lot of these cash flow come from future, right? If the interest rate is lower, meaning that those values were not deflated too much, so you should be ended up with a higher present worth. If the interest rates are very high, so the future return becomes in terms of present worth become smaller, then it will reduce their value, so that your present worth could be smaller, and even from positive to negative, which can be illustrated by this table. We have 15% at the time. When it reached 17.45, interest rate equal to 17.45, your net present value becomes 0. But when it's smaller than 17.45, including 15%, I mean, and you can see that all the present worths are positive, and when it reaches 0, it has the largest present worth. But as it gets bigger than 18%, then it becomes negative and all the way, and the negative values become bigger and bigger, meaning that your investment, although you recover some money from the future, because those money are deflated, worth a lot less, in fact. So in the end, you may even lose money. Okay, that is the point. So you can even look at this from this graph, as the value of interest get bigger, then your present worth will become smaller and smaller. And this particular interest rate you choose is also called minimum attractive rate of return, MARR. MARR. You specify a value, MARR SI, meaning that you are using a certain interest rate as a basis for evaluating your investment opportunities. Okay, it has to be, it is a value that we use to represent our perception or our expectation of how the money, the investment should return. Okay, this value we'll consider again in the future, but that's something we define. We just say that, okay, I'm thinking that we should have 15% return, and you calculate the result. So, okay, it's greater than, if it's greater than 0, it means that it's more than 15%. If you are thinking of, I think I want to have 20% of return, otherwise I won't invest. So we took you 20% into this conversion. Then we found out that if we consider 20%, then we found out that with the cash flow that we see, it will only give us a negative value, negative present worth, meaning that the return of the investment will not reach 20%. Then you will reject. So choosing an MAR is very, very critical. It will change your result of analysis. Okay, but based on the figure, you can probably see what was going on. Okay, so that 17.45%, as we seen, as we saw in the previous slide, is the break-even interest rate. Okay, it is the minimum attractive rate of return that we define, and at that point is the break-even. If it's bigger than that, then this investment will not be accepted because the present worth will be negative. So as we showed here, smaller than 17.45 accept, greater than 17.45 will reject the opportunity. Okay. So earlier we mentioned that all the criteria should come to the same conclusion if they are the decision rules that give us the most rigorous result. And we also mentioned that when we are comparing cash flow or considering the value of the money, we can convert them, all of them, as long as converted to the same point, whether or not it's to the present time or the end of the first year, the end of the second year, and so on. They should give us the same analysis result. So we were talking about net present worth. We can also look at so-called future worth, right? Because future will be just the end of the project or somewhere in between. Because if we convert them all to the same point, or convert the project to a certain point, if it gives us a positive value, then we'll accept it. Okay, just let us look at the future value. So it's just very similar to what we had before. We have a project, we have investment, and there are some return, and the end of the project is the end of the third year. Okay, that's the project life. Okay, we want to evaluate the value of the project at the end of the project life. So we take all the cash flow to the end of the project life. So everything is given P, find F, and depending on how far away it is from the future. So consider inflow, which are these three, So I have three values. Given P, find F, we come up with value, we add them together. Similarly, we compute outflow, we'll have only one outflow. So this 75,000 is at present. We want to convert it to the future, which is the end of the project life. Then we will use given P, find F, and the interest rate we designated, and also 3 periods, 1, 2, 3. So it will be compounded 3 times. So we'll get 114,000 roughly, and we subtract outflow from inflow and get a positive number, 5,404, which is greater than 0. So we'll accept this project. So if we take all the cash flows to the present time and compute its present worth, the result will still be the same. That is, we'll get the present worth, a value greater than 0, and we'll conclude that we'll accept this opportunity. Okay, that's the result. So again, inflows, outflows, and the result is we'll accept. Okay, because the net is positive. So this decision rule tells us if it's positive, then we'll accept. If we look at this from a little bit different perspective, that is, we want to see how these things happen. Still similar to what we look at the net present worth, we look at the payback period, discounted payback period. The money is, in fact, although it hasn't gone through the transaction, but along the way, in between the one period, the exact value was in fact changing. Just that we will only update the final change at the end of the period. So we can think of the problem in the previous slide, and we took the table horizontally so that we can correspond to the diagram later on. So we have period 1 now, and this is period 1, this is period 2, this is period 3. And in the beginning, we have a payment, we have investments, 75,000. Then again, over this period, there's cost incurred, right? Interest. So add them together, and there's some return, and we get 61,850. And this value will be beginning balance. You will accumulate some interest again, and there's some return. You add them together, you get this value. Again, you take this balance as the beginning balance for the next period, because the end of period 2 and the beginning of period 3 coincide. Okay, and you will compute this interest cost, and you add them together and add payment too, and now you have a positive value. So that is the end of the project, and based on the 15% minimum attractive rate of return, meaning that for this investment, in fact, I'm thinking of 15% of return, and based on that designated MARR, I still have plus, meaning that the investment, in fact, generate more than 15% of the return, and the present future worth, the future worth also show that present and future worth will both show that result. Okay, so it's a positive value, and we'll accept this this investment opportunity. If we can compute, as I said, the present worth, will also come to the same conclusion, that is 3,553, which is positive. If you look at this from the cash flow diagram, okay, which we have seen previously, imagine that you have invested 75,000, and over this period it will increase because there's interest, but you pay something back, and you will start to accumulate more interest, and you'll get something back, and yours continue to increase, then you'll get something back, and that something back exceeds more than the money you haven't recovered. The result is a positive value. Okay, so this is something quite useful for you to visualize how things happen. You have money invested, and over a period of time, this money that you haven't recovered is creating additional costs, and so when you are considering the return, right, you in fact have more value so that you can recover your initial investment. So this diagram and this concept, you can trace back to present worth. You can also trace back to discounted payback period. Okay, so discount period, payback period is 3 point some years, right, as we have already seen earlier.